Alright, so this is section 4.1, properties of linear functions. We're going to just go through these 9. It will be helpful for you to go through the textbook. Like if you look at some of the examples and definitions, and then you look at these videos, it will, kind of solidify some of the things that you see in here. We're going to be talking about linear models mainly, so you get the definition of what a linear function is. Talk about average rate of change, and they give you some visuals as well. These things I'm going to be using in the section. This notation may or may not be familiar to you, but this is called the change in y and change in x. This is how you find the rate of change or the slope, and they just show you what it means. So change in y, you take the difference in the two y values. Now it looks weird because they're showing you f of x, but this means y2. So you have your second x point, and that gives you your second y value. So this is x2, this is your y2. They should be lined up vertically, and then you can find rate of change. So this, along with other examples, real world scenarios, we'll be looking at in this section. So do take some time and look through the text. It will help. So this first example wants us to find the slope of the 2 points. So we've seen slope formula before. It is just m equals, and I'm writing it in a different format, y2, different than what you just saw in the book, y2 minus y1 divided by x2 minus x1. It's the same exact formula, just different symbols. We have these 2 points. We have the ordered pair 1, 2, and the ordered pair 4, 1. Okay, so I'll call this x2, y2, and this will be x1, y1. And we'll just plug them in and find the slope. So y2 is 1, y1 is 2. So we subtract. x2 is 4, x1 is 1. When we subtract, we get a negative 1, and then 4 minus 1 is 3. So we get a negative 1/3 for our slope. Alright, question 2 says a car has 12,500 miles on its odometer. Say the car is driven an average of 40 miles per day. Choose the model that expresses the number of miles in that will be on its odometer after x days. Okay, so this nx, this says this is a function of the number of miles that will be on its odometer. That's what n stands for. So x, what they tell us after x days. So x days will have this many miles. Alright, so we are driving 40 miles per day. So this is your rate of change per day, 40 miles per day. Whenever you see that per, this means we're going to be multiplying times 40. What are we multiplying times 40? The day. Okay, so we're looking for 40x, because x stands for days. So 40x, this one has 40x, but it has negative. And we're not taking miles off, we're adding miles to. So I need a positive 40x. This one here. And we're going to add the original miles that were on the car, the 12,500. So equation C is what we would use to find out the number of miles on the car after x days have passed.